Hello everyone, I'm Quentin. I'm a software developer. I've been coding in Go for 2 to 3 years, professionally and for personal projects. You can check my GitHub. I have a bunch of Go projects if you're interested into that. Today, what we're gonna go over is about writing a simple function and writing a test for it, a great test. I can assure you that. So the function is pretty simple. It takes a slice of IP addresses, which can be IPv4 or IPv6, and it returns a slice of IP addresses. What it does on them is it removes the duplicates and it sort them. Why? Because if I have a slice of IP addresses and then I don't know, I do some magic and I get another slice, I want to quickly see the differences between the two. This is used in a project called Gluten, which is a VPN client, and it is used to resolve host names to IP addresses and have hard-coded IP addresses in the program. So anyway, let's go to it. So how are we gonna do that? For now, it just return. It doesn't do anything for now. So let's start with we're gonna create a set. A set. How do you do a set in Go? You do a map of struct. So let's call it unique IPs. Unique IPs. Oops. All right. We're gonna make it map. It's gonna be a map of strings and struct. The key is string. The value is struct. Empty struct means 0 byte. In Go, that is the smallest thing you can do. Even bool is 1 byte, I think, or maybe even yeah, I think just 1 byte. But anyway, struct is 0. So use that for a set. Um, Okay, little optimization. We're gonna create it with the length of IPs because usually there are no duplicates, but sometimes you never know there may be duplicates. So you create it for the size of IP, so you only have one allocation. You don't want to have multiple allocation. It is a bit faster in some cases, especially because these numbers are not going to be huge. So we can pre-create the map with that size. Okay. Anyway, let's move on. Now what we're gonna do, we're gonna iterate over the IP addresses as input, and we're gonna took set as the so let's do the key is gonna be ip.string. Where's it? Oh yeah. All right, ip.string here and here an empty struct. Done. So that is 0 byte for all of them, and the key is y. Oh yeah, oopsie. All right, the, there we go. So the key is the IP as a string representation because IP is net IP. What is net IP? Net IP is a slice of bytes. So now what we want is just the string representation. So to be sure, that's what the map likes as well. They like string keys, right? And this we can be sure that the way we'll see it, we're gonna remove the duplicates, whether it's like some weird bytes or whatever. Like I don't know, if it feels safer this way. So let's use that. Okay, now what we have unique a map, well, a set of unique IPs in a string uh, type, we want to put that back to net.ip object. So how are we gonna do that? We're gonna iterate over the unique IPs. Oops, that's the key. Sorry. So actually, I can say key here. All right, we have the key here, which is remember the IP as string. And now what we want to do is converts it back to an IP address. So we're gonna do net.parseIP and key. Great. Okay. And what we're gonna do is, okay, we want to assign it to the output, right? Uh, for let's say to stay concise, right? Yeah. We're gonna create a slice of net IPs using the input because we don't need the input anymore. So we're gonna make it, and we're gonna make it the length of unique IPs, so that we don't do any memory reallocation. We just do one memory allocation here, and then we just assign to them. Um, okay, fancy little thing here. We're gonna put 0 as the size of the slice, but assign the length of the unique IPs as the capacity of the slice. So that's interesting because this means, for example, IP.0, there won't be anything. It will panic. But we can append to this slice and the size will grow, and this won't do any memory reallocation, which is great in terms of performance. So you may want to use that, especially if you fill it from a map because you don't have an index at the map. So otherwise you would need to, set I equals 0 here and then increase it here, and etc. It's like a bit messy. So this way is a bit cleaner and has the same performance. So anyway, let's go. Let's continue. So we're gonna append from IPs to IP. All right, then done. Okay, no, not done. We sort now we removed all the duplicates. That's great. And now what we want to do is sort dot slice. All right, we want to sort it. So we just pass IPs and we pass a function to sort it. All right, these are going to be integers indexes. Call them ing, and we're going to return. We're going to compare the bytes, uh, which is going to be IPs I and IPs J, if I'm not mistaken. All right, yeah, whatever. As long as they're all the same, I'm happy with that. Cool, 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 cool. All right, now we have removed duplicates and we are sorting the slice. Great. Now let's go to the test on the right side. So this should work, but we want to test it, right? So that's why we're gonna create a file. Well, it's already created. It's called ips underscore test.go. It is, well, maybe it's a bit too small for you to see, but it is in the same directory as this file, which is called ips.go. This one is called ips underscore test.go. That's how Go uh, knows it's a test file. So what we're gonna do, test is a function. So test, I'm gonna call it unique sorted IPs, the same as the function on the left. All right, this I'm gonna. All right, that's the first thing. T.parallel. Oh, what is this? Not many people use that actually, but you should definitely use it. What it means is that the test is gonna run in its own Go routine, and it means it can run in parallel with other tests that have this called T.parallel. This is great because, well, it runs all the tests in parallel, which might be faster, but that's not the key argument. The key argument is that you can detect race conditions, and that is crucial. Almost no Go developers I know about that, but I love this thing. So what you can do is, okay, you need G++. You need to install G++ because that's a the race detector coming with Go is a C++ thing, right? So you need to have G++ installed. Usually it's installed on like OS X and all that, but it should be coming bundled with the Go toolchain on Windows as well. On Linux, sometimes you may need to install G++, like Alpine, for example, if you run it in a Docker container, you will need to install it. Anyway, so how you do it is you set, just to make sure, you set it to 1, Cgo, and you run go test race and all the tests at the root of your project, of your Go project, right? So that will show you any race condition that happen between the different tests running in parallel, and that is super useful because you don't need to run your program with the race detector, which is really slow and really resource hungry, and it sucks. Anyway, so that is a great way to avoid all that and have an easy way to find race conditions. You, especially in Go, because the thread safety is not that good. Maybe Rust is a bit better, for example. It's another programming language, but you want to run all your tests in parallel and check with the race detector if you have any race condition. Anyway, so t.parallel, that is done. Now we're gonna do test cases, which is gonna be a map of string. String is gonna be the name of the test, and struct are gonna be input and outputs in this case. So we're gonna have input IPs, net.ip, all right, and we're gonna have output IPs, which is gonna be the output. Let's start with one case. We're gonna call it nil, which is gonna mean input. Well, all right, input IP is gonna be nil. And output IP is going to be, uh, let's say nil. It's not going to be nil, but for now, let's just pretend. All right, I saved it. I imported .NET standard package. Okay, so we have test cases. Now what we want to do is iterate over the test cases. So branch test cases. Um, okay, we're gonna run them as subtests because this thing exists and they're nice. So we're gonna run t run. Oh my God, I'm not used to. All right, wait. Oopsie. All right, we're gonna run another test function in there. And what are we gonna put here? We're gonna put output IPs equal the function we want to test, and we're gonna put in the test case input IPs. And we're gonna use asset, which is a third-party package, but it's very nice. Please use it. And we're gonna asset that the output IPs we expect are the actual output IPs. Asset is imported from github.com, stretcher, testify, slash asset, and it's really great. There's also require that you may want to use, which fails the test instantaneously, but most of the time asset is enough. It just saves you from using, refract or CMP and stuff like that, and writing if and else's everywhere. It is really nice. It shows the difference quite nicely as well. Globally, I'm quite happy with it. I didn't find a better replacement, so you should use it. Um, Okay, let's try it. Running a test. Oh, all right, it should be there. Wait 1 second. Fail. Ooh, ooh. I feel hurt now. Okay, why? Because it's an empty slice, not a real slice. Why? Because we make slice. We make this slice here, right? On this one, we make it. Even if it's gonna be 0, 0, it's gonna be empty, but we make a slice. But that's fine in our case. We don't really care. So let's just make it to an empty slice. All right, done. Okay, we're just run the test. It's gonna pass now. Yay! All right, passed. Now, yeah, just don't worry about the coverage. That's because it's in a package with a bunch of other things. But we are concerned about this function for now. We can see the coverage in green and what is not covered in red. That is a setting in VS Code you can enable. Um, okay, so let's try. Second case is gonna be we're gonna pass in an empty slice. I'm just trying everything coming from my mind. I'm not really taking care about the coverage here. I always like to test it every corner cases, and that should do it. Let's run it. Oop. Oh, forgot the comma. Shame on me. All right, it's passing. Great. Okay, now let's do single IPv4. I'm just gonna stick to IPv4 because I can be asked. Right. All right, let's do the Cloudflare DNS. Let's try it, and this should give this one. Same one, right? Because there's only one IP address. So let's see. Oh, surprise, surprise. Wait, let me remove that. All right. Surprise, surprise. So wait. Okay, maybe you let me make this bigger because otherwise you cannot see. All right. So surprise, surprise. We were expecting this as well, 1.1111, and we got a bunch of zeros and this weird FF 255. What is this? And or ones at the end. That is because Go treats net.ip as a slice of bytes, and it takes all this room. All this is for IPv6. So I guess in its way, this signals. This is a way to signal that this is an IPv4 and not an IPv6. That's how Go knows what is an IPv4 address and what is an IPv6 address. And I don't really like it. That just I could adapt my test, but in this case, I'm just gonna change the code on the left. So how we're gonna do that is pretty easy actually. In this case, I'm just gonna say if IPv4 is equal to IP24, and here, so here's the condition. Okay, so the condition is IP is actually an IPv4 address. If it's not, we just don't do anything. And if it is, we assign it to the IPv4. So in this case, it's a funny Go thing you can do is assign something and do a condition on it at the same time with the semicolon. It's a bit of a pro thing. So anyway, there. Now let's try it. Should work now. Yeah, it worked. All right. So now it trims away all the rest of the bytes, whatever FF that was inserted, and we just have our IPv4 that we care about. Now let's do two IPs. Two IPv4 with an S because I like to be grammatically accurate. We're gonna do this and okay, let's do two here. All right. So what should we get? I guess the opposite. I guess. Let's cross the fingers. It's gonna be the opposite. All right. That should sort it. Yay, that works. Wow, first time. All right. Okay, so pretty much we have full coverage now. The sorting works as well. There's not really a point in. You can add more IP addresses. You could try with IPv6 as well, but I don't really care now. I think that will be it for today. I hope you enjoyed it. Let me just lower this so you can see the whole test. Oh wait, actually, I forgot about something big. This subtest we can run it in parallel, but big warning here. You need to pin the variable. So we need to pin test case here. You oops. All right, here. You can do it here or you can do it here, but you need to do it before the t.parallel because t.parallel is gonna run it in the Go routine, and we don't pin the variable. And because of the for loop, if you don't pin the variable, you might, if you have a lot of test cases, for example, and the Go schedule takes some time to start the Go routines, um, you might take some time. Um, you might use the last test case for all the subtests, which is not what you want. You want to run a subtest for each test case, right? So be careful with that. You need to pin the variable like this. It's really silly, but that's how it is. So it's a scoping thing, parallel thing, Go specific thing. Um, all right, and that should work as well. And all right, well, let's run it for the sake of correctness. And yeah, it worked here. Oof. All right, here. All right. So test cases, please don't use a slice. A lot of people use a slice. You can use a map of string to struct. There's no point putting the name in the struct, the name of the test. Just put it as the key of the map. That is much better, much cleaner in my opinion. And in the struct, put whatever you want. Here is a simple test. In coming with videos, I will go over a more complicated test. Some about Go routines, some about maybe mocking things with interfaces. Not many Go developers seem to know that as well, and I figured like I should share about it. That would be useful. Finally, I just want you, if you are curious about my setup on VS Code, I made a great project which is called Go Dev Container. Even has a nice icon here, right? And which basically allows you, it's really easy to set up. It's like three things. You just need to follow this with VS Code, right? You need to install Docker, Docker Compose, and the VS Code remote containers extension, and it allows you to run the whole thing, like Go, the linting, the test settings, everything, like in a Docker container. So it doesn't pollute your host system. It runs quite well. It runs well on Windows. OS X, I had some trouble on a laptop, but yeah, it runs pretty well on everything. It runs better on Linux, obviously, if your host is a Linux. Um, but it's great. It's super nice, and I maintain this with the latest everything, latest Go version. It runs on Alpine as well, so it's meant to be lightweight, let's say, and secured. So you have a nice shell, for example. I can show you here. Um, ooh, this is small. Okay, okay, I cannot zoom. Sorry, but yeah, it is a Linux shell. If I do uname the dash a, yeah, I got the Linux 4.19. So yeah, it's pretty fun, and you can easily update all your development environment by pulling the image again, which is built every week, I think. So yes, if you want to dive right into Go with VS Code, you should give a try to my container. Okay, I hope you enjoyed this video. I will see you around for the next video. Please comment things if you want any video about anything. I will be happy to answer it. Have a good day. Bye.